Hello students, welcome to the second part of our exploration into basic algorithms. In this session, we are diving into a crucial area of computer science that influences how efficiently we process and organize data. Algorithms are the foundation of problem solving in programming, and today, we'll focus on one of the most practical and widely used types, sorting algorithms. Let's start by understanding what sorting is. Sorting is the process of arranging a list of elements in a specific order, either ascending or descending. It's a fundamental concept that makes it easier to search, analyze, and process data effectively. There are various types of sorting algorithms, each with its unique approach and purpose. On this slide, we have listed 5 popular algorithms: bubble sort, insertion sort, selection sort, merge sort, and quick sort. Now, let's discuss bubble sorting. This is one of the simplest sorting algorithms, but also one of the least efficient for larger datasets. Bubble sort works by repeatedly swapping adjacent elements if they are in the wrong order. As shown on the slide, in the first pass, the largest 8 is moved to its correct position at the end. This is done by comparing each pair of adjacent elements and swapping them if necessary. In the second pass, the second largest element, 5, is placed in its correct position, and the process continues for the remaining elements. By the pass, the array is nearly sorted, and fewer swaps are needed. Next, we have the selection sort algorithm. This method is a bit different from bubble sort. Instead of repeatedly swapping adjacent elements, selection sort identifies the maximum element in the unsorted portion of the array and places it at the correct position in each pass. Here, during the first pass, the largest number, 98, is identified and swapped with the last element of the array. In the second pass, the next largest element, 87, is found and placed in the second last position. This process repeats, with the unsorted portion of the array become smaller after each pass, until all elements are sorted. Now, let's discuss merge sort, a highly efficient and widely used sorting algorithm. Merge sort is based on the divide and conquer principle. Here is how it works. Step 1. Splitting. First, the array is divided into smaller subarrays until each subarray contains 1 or 2 elements. This is done recursively, as shown in the diagram. Step 2. Sorting and merging. Next, pairs of elements or small subarrays are compared and sorted. These sorted sublists are then merged into larger sorted lists. 3. Final merge. The process continues until all sublists are merged back together into a single, fully sorted array.
Finally, let's explore quicksort, another powerful sorting algorithm. Quicksort is based on the divide and conquer strategy, but it approaches the problem differently than merge sort. The key process in quicksort is the partitioning step. Here's how it works. Choosing a pivot element is chosen, which could be any element in the array. Partitioning, the array is rearranged so that all elements smaller than the pivot move to its left, and all elements greater than the pivot move to its right. This positions the pivot in its correct place in the sorted array. Recursion, this process is applied recursively to the subarrays on either side of the pivot until the entire is sorted. As shown in the diagram, in the first step, 70 is chosen as the pivot. The array is partitioned around 70, and then smaller pivots like 50, 40, and so on are used in subsequent steps. The process continues until all elements are sorted.
Thank you for joining today's session on sorting algorithms in C. We have explored the basics of arranging data efficiently and the variety of approaches that different sorting algorithms offer. Mastering these concepts is a vital step toward becoming a proficient programmer. Let's open the floor to any questions or discussions you might have.